Now members, let us see this formula here. Show that the Newton's formula for finding the cube root of any number n is given by this. Then for n equal to 0 and so on. Hence use the iterative formula, find this one means a cube root of 96, correct 3 decimal places. So there what we do is know that our formula for the Newton's method is this. Now after that, you know that they are telling us that the cube root of any number. So I say the cube root of any number which is n. I say that the cube root of any number n be x. Remember, in this formula we need a function and its derivative. So meaning if this is the same as x equaling to n power r3. The cube root is the same as this. So if we cube both sides, it's that our x cubed will be n power r3, the whole cubed, this and this will cancel, and it's that our x cubed will be equal to n. So we need to form an equation out there. So it's that now from here, it's that now my x cubed minus n is equaling 0. So if I let now this be a function, remember we said the power function should be equal to 0. That's why I will take this the other side so that I create this. So I said that my f of x be x cubed minus n. So now if I differentiate this, remember we need fn of this, also need its derivative. So when I differentiate this, square root plus minus 0, which I can leave like that. So here we need now f of xn, which will be x cubed n minus n. Then here I need f prime of xn n squared, as you can see, this and this. Now substitute into this formula will be now into this the whole over. So if I cross multiply, you see this is going to multiply this. I'll be having 3x cubed n, then plus n, the whole over. Here we are getting the LCM. So see if we simplify that. So this one is going to give us 2xn cubed, then plus n, the whole over 3x squared n. If you factorize out 3 according to this, if I factorize out 3, this is 3, and then I divide, you see if I separate here, this will be, this divided by this, I have 2x n over 3, then plus, if I separate, n over 3x squared n. This divides this, you get this, then this divides this, you get this. Remember, this is the LCM for both. That's why I'm dividing like that. Now it's starting now from that to factorize out this side. So removing that side, my xn plus 1 will be now a third into 2xn plus n over x squared n. And I think you see that is our the one that's handle. So after doing that, now you see for n, of course, for n equaling 0, 1, 2, and so on. So now they want us, and hence use the iterative formula to find this. The iterative formula is now when we are going to get the roots and then correct 2, 3 decimal places. Now, because they are telling us correct 3 decimal places, now our term is going to be 0.5 times 10 power negative 3, which will give us 0.00005. So this means that now the difference between xn and xn minus 1 should be less than 0.005. 0.0005. So now, now the question is, what is going to be our initial value? Now, you take, when you get the cube root of 96, it's 4.5 something. Now you can say, let my initial root be, let x not be 4.5. Why am I choosing this? Because it's close to the exact root. Okay, of the exact root of the cube root of 96. So that's why I'm choosing it. You don't choose the right one, but you choose the value close to it. Okay, so after choosing this, now it's that I'm going to use this method. So from when n is equal to 0, the initial root, this one is going to be x, now 1 equal to a third into 2 into x naught. Now our x naught, we are taking 4.5, then plus, now our n is that from here, if we compare our n, if we compare the cube root of n and our n cube root of 96, is that our n is 96. So meaning that my n is going to be 96 over now 4.5 squared. So here my x1 is going to be, when I put 4.5, I have already how to put these values. So I'm getting 5802. I'm giving now this to 4 decimal places because they want my answer is 3. When they want your answer is 3, you give to more decimal places. And so when I subtract this from this, the tolerance is not 0. So you see that my x1, my x naught, you see when you subtract here, this from x naught, our x naught, where is our x naught? This one, our x naught here. You get 0.0802, which is not less than the tolerance. So meaning we move for another. So when n is 1, we have x2 equal to a third into 3 into, now this value to now plus 96 over 2 squared, then it goes brackets. Our x2 here, we shall get the value I'm getting is 4.5789. I'm giving also this to 4 decimal places. Now I come and I calculate to see what is my error. X2 minus x1. You see, if I subtract those two things, I'll be having 4 point. You see, it's just converging something 0.0013, and so that this one. You see, when you have this, remember our tolerance is this, and you see that it has not converged yet. So what we do, we move for another. You see this one, 0.015. This one is 0.005. So now we move for our x3 when n is 2. This will be now our third into 2. Now we shall use the x2, which is 4.5789, then plus 96 over 4 point now. This one 789, they all squared in. And so here our x3 will give us. So if I'm to put that onto that, sorry. So here I'm getting 4.5789. And you see that when you subtract this from this, you see that our x3 minus x2 is giving us, when you subtract this, I think you get 0.000, which is less than our total 0.0005. So implying that is going to be our value. So mean that now our x3, which is equal to 4.5789, is now, if you round up 3 decimal places, you get 4.579 here. I'm giving 3 decimal places, and that would be the value. Here, our torus is very okay. It's less than this error, which this one wasn't, this one is not, less than 0.005. So, this one becomes our value. So, that's it, members. See you next lesson.